Hi. Today we will present to you about Wheatstone Bridge. It also known as Resistance Bridge. Before that, this our group member. Hi. My name is Ahmad Aiman bin Daud. 202462. Hi. My name is Nisha Wardina Binti Zulfaizal. 202741. Hi. My name is Lutfirrahman Bin Anuar. 203730. Hi. My name is Hairul Faizi bin Hairulnizam. 200942. Let's start our presentation.
Hello everyone, so in this video, we will be presenting about Wheatstone Bridge. Let's start with some history background. It is developed by Charles Wheatstone that is used to measure an unknown resistance values. However, in today's applications, it is being used to interface various transducers and sensors to these amplifier circuits. For the next part, let's proceed with the construction of Wheatstone Bridge. Let's look into the circuit, which should contain one voltage source and four resistors. For resistor 1 and 2, it should be a known-value resistor, and for R3, usually we will use rheostat as we can vary the value of the resistor. And back to the function of the circuit is to measure unknown resistance value, so Rx will be the unknown resistance value. Next, we will be explore about the working principle of the Wheatstone Bridge. Let's look into the circuit. For the left node, it will represent VC, and the right node will be represent VD. So, the working principle of this circuit is to make sure the potential difference between VC minus VD will be equals to 0. Hence, the equation of R1 over R2 is equals to R3 over Rx is equals to 1 to make sure the bridge is balanced.
Example of Wheatstone Bridge.
Now we will go for the example of the Wheatstone Bridge circuit. If R1 equal to 1 ohm, R2 equal to 2 ohm, and Rx equal to 3 ohm, so what value should R3 be adjusted to achieve a balanced condition? For B, if V not equal to 6 volt, Ra equal to 0.1 ohm, and Rx will then deviate by a small amount to Rx equal to 3.01 ohm, so what should be the reading on the ammeter? So this is the circuit that we are going to discuss today. So for question A, we will do ratio formula. So R3 over R1 equal to Rx over R2. By doing substitute the value and change the place, we will get R3 equal to R1 times Rx over R2, and when we substitute the value, we will get 1.5 ohm for R3. So next we will do for question B, we need to find the ammeter current that is IA in the middle. So next, what we need to do for this question, we apply the KCL equation at node V1 and V2, which is I in equal to I out. So I1 equal to I3 plus IA, and I4 equal to I2 plus IA. Next, we also will apply the KVL, Kirchhoff voltage law, for the left loop and outside parameter loop. So negative V0 plus I1 R1 plus I3 R3 equal to 0, and also negative V0 plus I2 R2 plus I4 Rx equal to 0. We also need to apply for the upper triangle of the bridge, which is I1 R1 plus IA RA minus I2 R2 equal to 0. And next, we will apply the simultaneous equation from 5 equation that we have done just now. When we apply, we will get the IA, the ammeter current, as the subject, Then when we apply all the substitution for the value that we have, then we will have emitter current equal to negative 2.5 milliampere. So that's all for the example.
Hello everyone, I'm going to tell you about the application of Wheatstone Bridge. One of the most common Wheatstone Bridge application is strain measurement. So, what is strain measurement? Let me explain what strain measurement is. Mainly, strain measurement is used to measure the amount of deformation that a material experiences due to an applied force or pressure. We call it strain. As you can see, the picture shows the changes that happen to the tube box when a particular force is applied to it. When a positive pressure is applied to the box, it is known as tensile and makes the box elongates. When a negative value of force is used, it is a compression and makes the box tend to expand.
So, now we have known what strain is. Next, strain measurement is a non-dimensional value representing the length of a material relative to its initial length. Usually, the changes are minimal. Hence, the unit used for the measurement is a micrometer per meter or microstrain. This is the strain measurement circuit. Due to the extremely small resistance change, Wheatstone Bridge is used to convert the resistance change to a voltage change. R1 is the strain gauge. Strain gauge consists of a flexible insulating backing that can support a metallic fall pattern. The fall can deform and change the resistance. Strain gauge resistance is typically measured in the range of 30 ohm to 3000 ohm. The Wheatstone Bridge is the electrical equivalent of two parallel voltage divider circuits. R1 and R4 compose one voltage divider circuit, while R2 and R3 form the second voltage divider circuit. The output of a Wheatstone Bridge, E0, is measured between the middle nodes of the two voltage dividers. From this equation, you can see that the voltage output E0 is 0 when R1 over R2 equals to R4 over R3. Under these conditions, the bridge is said to be balanced. Any change in resistance in any form of the bridge results in a non-zero output voltage. Therefore, if you replace R1 into the circuit with an active strain gauge, any changes in the strain gauge resistance unbalance the bridge and produce a non-zero output voltage that is a function of strain.
Next, we will talk about a common error in Wheatstone Bridge. The first one is galvanometer is less sensitive, thus inaccuracy occurs in balance point. The second error is the resistance of the bridge changes because of the self-heating, which generates an error. Next, the thermal EMF causes serious trouble in the measurement of low-value resistance. The last common error is personal error that occurs in the galvanometer by taking reading or by finding the null point. The above-mentioned error can be reduced by using the best qualities resistor and galvanometer. The error because of self-heating of resistance can minimize by measuring the resistance within a short time. The thermal effect can also be reduced by reconnecting the reversing switch between the battery and the bridge. The last part is the limitation of Wheatstone Bridge. The first limitation for the bridge is not so precise when it is used to measure large resistance. Next, the value of the resistance degrades depending on the temperature and the EMF applied. The Wheatstone Bridge also gives an accurate reading if it is unbalanced. The last limitation is the bridge only measures resistance from few ohms to mega ohms, and the results are mostly non-linear.
That's all from us about Wheatstone Bridge. Hope you guys enjoyed the video and learned something today. Thank you.